Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue talking about networking, and we want to take our little networked program that we wrote last time and turn it into actually a chat program that will allow multiple users. So the program as it stands right now opens a server socket, accepts one connection, and then opens the input stream and the output stream for those, writes a little bit and reads a little bit, and that's all it does pretty much. Okay, so what we want to do is we need to make it so that we can accept lots of connections, okay? And then keep a list of users. So why don't we go ahead and make the list of users. And I say a list of users, but this is something that needs to be able to change over time. And so probably the ideal here would be to use a mutable buffer, and we'll make it a mutable buffer of what? Well, it could just be of sockets, but it turns out that we want the socket, we want an input stream, we want an output stream, and we might also need, for example, the user's name associated with it, and other information if we were to push this further. So why don't we go ahead and create a type called user. So let's make a case class for a user. It will store a socket. It will store the input stream. We might revisit this in just a second. Actually, we will. Because we want to make the types match exactly what we're going to use. Actually, well, you've seen that our output stream, previously we did a print stream that allowed us to just do print lines. And let's make it so that we get their name. And do the imports. We also, for the buffer, import collection.mutable. All right, some parens. Okay. So this sets up users, and so we create a server socket, and then we accept. Now, once we've accepted a user, what we should be doing is adding them to our buffer of users. However, this at the same time, so imagine, instead of right when the program begins. Right when the program begins, it's fine. It does absolutely nothing until the first person connects. But after 2 or 3 people have connected, if you picture what's going on, those 2 or 3 people are chatting, and we can't make a call to accept because it's a blocking call in the middle of their chat. Otherwise, you can't say anything until someone new connects. And that's not really a reasonable thing for us to do. So we need to have it so that this part of the code is going to happen off in a separate thread. And we will use the approach of, actually, I don't know if I need an import for this. So I'll make an actor, and I'm using the actor library just to create a thread. It's doing nothing else other than creating a thread here. And what I'm going to put inside of this thread is actually an infinite loop. Okay, why? Well, at least and we could talk about, there might be some alternatives that we could do to this, but at least for now, how many users are you going to accept? Who knows? Okay. A lot of times servers don't have, or if they have something that takes them down, it's not after some fixed period of time, it's when a user enters a command. And so if we wanted to have the user enter the command, we can do something like a call to sys.exit when we're ready to exit. And so this is just going to be an infinite loop over here in this thread. It accepts a new socket connection. We'll get an input stream and an output stream for it. And then what I want to do is I want to take users and add onto it a new, actually this is a case class, so I can just say a user of the socket, the input stream, the output stream, and their name. We don't have a name yet. Okay. Already here there are some issues, and if you think back to the multi-threading, things that we have to deal with. I am adding on to users here, but down below, what's going to wind up happening? Well, I'm going to be checking if I can read stuff. I'm going to be reading, and I'm going to be running through all of the users and checking to see if they have something to say, and then sending out their data to everyone else. But here I am simultaneously incrementing the users or adding on to the users. So I'm going to have this one mutable collection that's being used by two separate threads simultaneously. And hopefully that just jumps out to you and says race condition. Okay, so how can we deal with this? We talked about a number of parallel data structures in the chapter on concurrency and multi-threading. We're actually going to take a slightly different approach. We're going to use the Scala libraries here, and inside of the collections library, inside of Scala collection mutable, if you go down to the end of it, there's a number of different things that start with the word synchronized. And as you know from the chapter on multi-threading, this means that it is supposed to work well across multiple threads. And so there is a synchronized buffer, and I have it pulled up here, and it says that this should be used as a mix-in. Now, that's a concept that we haven't really talked about, but it turns out it's very simple to do. What I want to do is to I want to make a new mutable buffer extends mutable dot and let's make this, I'll have to be specific about it being an array buffer. Let's look at our constructors for the buffer. Should just be able to that's not what's going to fix this particular problem. Expected semicolon but found extends. With. Because we're doing this as a mix-in on a trait. So when you're doing the mix-in, you give it the base type that you want, and then this trait becomes the kind of interface that's set over on top of it. The synchronized buffer has all the methods of the array buffer synchronized, so that when we add things and remove things, it'll be safe across multiple threads. Okay, so that makes it so I feel a little bit safer here. The name. Okay, well, for that I need to read in a value from the input stream. And we came down here and we have this code where we can read in values. This was kind of bulky to do, though, to create a new buffer and then to read the buffer and then to make a new string from the buffer. It turns out that instead of using a buffered input stream here, I can wrap things in a different way. And so here we'll refer to the Java parts of the library. Inside of Java I/O, we can do a slightly different decoration, and I want to wrap my input stream inside of an input stream reader. Readers deal with character input instead of byte input, and the reason I want to do that is because then I can use a buffered reader, which, unlike the buffered input stream, it has a method called readLine. Now I have to admit, I didn't check this before starting to make the video because I like to kind of have these things be, in some ways, by the seat of my pants. But more importantly, to have it so that if I run into problems, you get to see it. These videos are not highly scripted because your programming will not be highly scripted. So you need to understand how to deal with things when you run into problems. Okay, so I'm wrapping a buffered reader around an input stream reader, and then that means that I can, for the name here, I could do something like is.readLine. And in order for this to be happy, this is going to be a buffered reader. We want to use the specific type because we care about the methods. I want to have access to read line and I want to have access to print line, which is why I'm using a print stream here. This code bothers me in one way, and that is the fact that this read line is inevitably going to block until the user types something. But that means we can't accept the next user until the one before them actually enters their name. Hey, we should probably have it print out their name too. So what I'm actually going to do is put this part inside of here. Okay, so this got me a socket and an input stream, and I want to immediately jump back and accept for a socket again, but have code that will ask them for their name and wait for it, and then add them onto the buffer in here. And I want that to happen in another thread. So I'm actually going to spawn another thread inside of here. So first let's do os.println of, and I'm tempted so that I don't have to flush here to get rid of the buffered output stream. We saw that last time. Println, what is your name? Val name equals is.readLine. Okay, or just, I already have that in there. Okay, so while we haven't tested this, we haven't verified that this works yet, this should accept a connection, create a socket, run through and make a buffered reader so that we can have the ability to call readLine, run through and make a print stream so we have the ability to do printLine, then start another thread where we're going to ask the user for their name, because this might take a while. They might take a while to type that in. And while that's happening in technically we have three threads. We have the main thread, we have a thread that's in this while true. This will start up a third thread which is going to sit there and wait for them. Now of course this thread, as soon as they're done typing in their name and we add this into users, it will terminate and the thread will go back to whatever thread pool the actor class is using. So we're not just making more and more and more threads, and this really isn't a very long process right here. This is enough for this video. We'll come back in the next video and we'll write the code that should go below this, which is the code for actually having the users interact and send messages back and forth.